Everyone, welcome to Answers with Joe. Today I'm going to be talking about NASA's big announcement yesterday about the discovery of 7 Earth-like planets around a star about 30 light years from here. Really cool stuff. But before I get started, I am going to turn down my sound because there's always a technical glitch. Before I get started, I just wanted to say to any new people out there, if you're not familiar with this channel, I highly suggest you check out some of my other videos. This is a live stream. This is not as, as well produced or researched or spoken, because I'm not as well spoken live, as my normal videos. So I suggest you go check those out. If you enjoy them, of course, I would love to have you subscribe. But if you are watching, I got about 40 people watching right now. Welcome, everybody. Glad to have you. And what I'm going to be doing is I'm just going to go ahead and talk about this whole thing. I'm going to lay it all out, everything that we know so far, put my own little spin on it like I do. And while I'm doing that, feel free to chat in the comments in the live chat on the side. I will not be able to respond until the end, but I'm going to get back around to the end and we'll do a Q&A and talk and stuff like that at the end of everything that I'm talking about, unless you do a super chat, in which case, of course, I will give you a big thank you because that's a very nice thing to do. So, looks like it's going. Looks like you guys can hear me. I'm not getting a bunch of people screaming at me in the live chat that they can't hear me, so that's good. We're off to a good start. Okay, so here's what happened yesterday. So NASA announced that they have found 7 Earth-like planets, or Earth-sized planets, around a star called TRAPPIST-1. It's about 30 light years away, and it's a pretty cool, discovery. It's exciting because not just do we have these Earth-like planets around this star system, but they are also in the habitable zone, the Goldilocks zone around the star where water could actually possibly exist. Water, of course, being the only thing that we know to make life possible, which is the only life that we know came about because of water. So if we look out for habitable planets, it needs to have some water, and we found that, and that's really exciting. So a little bit of the history of this discovery. So TRAPPIST-1 is a very small star. It's actually just a little bit bigger than the size of Jupiter. It was first discovered in May of 2016, or it wasn't really discovered, but it was first studied in May of 2016 from the TRAPPIST telescope in Chile. And this telescope is actually managed, and they use it out of Belgium. It's operated out of Belgium. But it's in Chile, and TRAPPIST stands for Transiting Planets and Planetesimals Small Telescope South. I had to look down for that because I couldn't possibly remember it all. But this is a planet that is, this is a telescope that is designed to find planets around other star systems. So the way they do this is they look for transiting planets. Now this means that in order to see it, that has to be kind of along the same plane. Like, the solar system is in a disk, and you have to be looking at the star, and the planet has to be circling around the star like this. I can show you a little transit image right here, I believe. If it's going to work. There we go. Yeah, so that's what a transit looks like. And we see that from here with Venus. Venus will circle in front of the sun. It's sort of like an eclipse, but because it's so small, they call it a transit. So that's what they were able to find with TRAPPIST-1. But they were able to detect, let me see, so they first found these back in May of last year. And they found 3 planets back then. And then they did extra observing. They got the Spitzer Space Telescope involved. It actually measures mostly in the infrared range, I believe. So they were able to see a bit more detail. And by studying for, I believe, 20 hours, 20 days, they studied it with Spitzer, and they found 34 transits at that time. And they were able to determine that that came from 7 different planets. So you might be asking, how do we know that these planets are Earth-like? Well, there's a few different things that we can do. First of all, there's that transit thing. So by looking at the dimness of how much it dims the star, when it does one of these transits, you can see how big the planet is. And actually, I've got a little image I can show you here. Let me pull it up. There's the transit image. I was looking at this. So that's the radiant flux. That's what they call the radiant flux. So you can see in the little dips down the bottom left where that's how much less these suns or the stars' radius, hello, what's the word I'm looking for? Radiance. That's how much less it dipped when the planets passed in front of it. So by looking at the dip, they're able to determine how big the planet is. But they're able to determine how dense the planet is by looking at tiny little wobbles in the star. And this is only possible in the last 20 years or so, to be able to see those tiny little wobbles in the stars to determine how much mass is in these planets. So once you have the size and you have the mass, you can figure out density. And that density tells them that these are rocky planets, which means they are Earth-like. They're not gas giants or anything like that. So that's exciting. So here's what we know about it. This is actually a remarkably small star system. TRAPPIST-1, the name of the star. TRAPPIST-1 is actually a very small star. They call it an ultra-cool M-class star. And again, this is like just a little bit bigger than Jupiter. So when you actually talk about this star system, it really is more like a moon system. It's really closer to Jupiter's moon system than the solar systems that we are aware of. So the furthest planet in this system is actually closer than Mercury is to our star. So it's very, very small. In fact, most of them rotate around, their orbits are only like 9 to 12 days. So we're talking about a week or a week and a half per year on these planets. So it's a very interesting star system. In fact, they're so close to each other that if you were standing on the surface of one planet and looked out, you would be able to see the other planets as big as our moon is in the sky. They're that close to each other. So, like, you know, we look up and we see Venus, it just looks like a really bright star. But they would look up and they would see the different planets in their night sky. So actually there's a picture of that I can show you. I got a whole bunch of pictures here. Let me show you what they would look like. Artist rendering, here we go. So that's actually an artist rendering of what it would look like if you were standing on the surface of one of the planets in the TRAPPIST system. You could actually see the other planets right out there like the moon in our sky, which is really cool. And by the way, so just here is a picture that shows how, that's not it. There we go. So this is TRAPPIST-1 as compared to our sun. It's way, way, way smaller. So this is like a pocket solar system. This is a very small, just really interesting, tight solar system, which is really cool. In fact, as I was showing you that picture of the surface, that artist rendering, here's a poster that NASA put out that is really cool. They do these little retro posters. I think you can buy them on the NASA website, and they put one out for TRAPPIST to show what it would look like in the night sky with all those planets out there. So that's pretty cool. So the gravitational effects of these planets, because they're so close together, means that they actually have some wobbles in their orbits. And we'll get back to that in a second. That makes a big difference when we're talking about life. But let's talk about that. Let's just jump right into life. And I'm going to take a sip. And I'm going to cover up my microphone because I was told that when I do my live streams, you can hear me swallowing, which sounds awful. I'm going to save you from that now, while I advertise for Dickies. Anyway, so it's really exciting. We found these planets. They're Earth-like planets. They could possibly have water. I'm going to throw a little bit of cold water on the possibility that they have life, though. I hate to do it, but we got to be real here. There's a lot of things that could be going against the possibility of these planets having life. And one of the big ones is that they believe they could be tidally locked. Now, tidally locked means like what our moon is to the Earth. The same side of the moon faces the Earth all the time. And the way they actually describe it, it sounds very confusing to me, but they say that it does rotate. It just rotates once every revolution. So it's always rotating at the same time or at the same speed that it's rotating around. Because these planets are so close to their star, and the reason why they can be so close and still be in a habitable zone is because the star is just so dim. It's a very small, very cool star. But because they're still so close to that star, it's believed that they could probably be tidally locked. They're putting their bets on the fact that they're tidally locked. So that means a couple of things. One, it might be very hard to have an atmosphere when one side of the planet is always facing the star. And obviously, without an atmosphere, it's very difficult to have water on the ground and life and all that kind of stuff. But you also need stability for life. And having a tidally locked planet would be very unstable because if you had an atmosphere, it's theorized that one side obviously would be really hot. You would have like Sahara Desert on one side, and it would be totally frozen over on the other side. However, because of convection currents, I believe is what it's called, but because it's always seeking equilibrium, the less dense air that's hot on the hot side would be trying to get around to the more dense, actually go the other way, wouldn't it? The more dense air on the cold side would constantly be rushing to the other side to fill in the less dense areas. And because of that, that means there would be probably very large storm systems. That would be a lot of swirling air and high winds and stuff like that. It would be very hard to maintain any kind of stability in a way that would create life. So the tidally locked thing, kind of a bummer because that's really a big strike against the possibility of it being able to contain life. But the other thing would be the fact that the planets actually sway each other in their orbits, which means the planets are constantly getting closer and further away from their star. And because of that, temperature fluctuations could go wild, and it would just be really hard to, again, maintain stability. You need a lot of stability. That's why our moon is so important to life on Earth, because it's kept our rotation stable this whole time. So now, it's not known for sure that these are tidally locked. It's only theorized. There's a lot of things that we don't know about it. The really exciting stuff is going to come hopefully next year. Although, well, next year in 2018, they're launching the James Webb Space Telescope. And I really need to do a video about the James Webb Space Telescope. It's super, super cool. And it's going to open up a lot more possibilities and things that we can see once it goes up. But one of the things that they're going to be looking at that they can do with the James Webb Space Telescope will be when they do those transits, it'll actually be able to pick up on the spectrometry, the spectrums of the light passing through the atmospheres of these planets, and they'll be able to tell what the atmospheres are made out of. And if it has a lot of organic elements to it, then looks like it could have some life. And I think through that same process, they'll be able to tell whether or not it's tidally locked and do that sort of thing. So maybe they won't be, but let's just play. This is where my mind starts to go. This is where I start to go, whoa, that's really cool. And I hope you will too. Let's imagine life on a tidally locked planet. Let's just say we're on, which one is it, TRAPPIST-D. So actually, let me pull up one thing. I'm interrupting myself real quick. There's a picture I did want to show of the TRAPPIST system. Where is it? Here we go. Give me just a second here. So this is the TRAPPIST-1 system, and they've numbered them B, C, D, E, E, F, G, H, because those are letters, guys. And the ones that they believe are in the habitable zone are E through G. And I think I got another picture that actually explains that a little bit better. These are the habitable zone planets. Yeah, there we go. So you can see in this image, and I'm going to leave it up for a second so you can look at it. There's some stuff to read there. The habitable zone planets are the E, F, and G planets. And they circle, again, you can see right down there at the bottom, their years are 6 days, 9 days, and 12 days. So these are very, very fast-moving planets around their star. But anyway, that gives you an idea of why. So the H planet is considered to be an icy planet. The ones on the inside are going to be way too hot for life. Is the E, F, and G that are in that nice little Goldilocks zone. So let's just imagine you're on one of those, E, F, or G, right? What would that be like? Well, first of all, I pointed out that you would be able to see the other planets just like moons in the sky, which sounds super sci-fi and super cool. I would love to see that. But tidally locked, what would life be like on a tidally locked planet? First of all, and somebody said this to me yesterday. I'm going to give Tom Mills. I was talking to him about this yesterday. He gave me he put this in my head, and I thought it was the coolest thing I'd ever heard. In a tidally locked planet, day and night would not be times. They would be places. There would be a day side of the planet. There would be a night side of the planet. And it wouldn't be a time thing. You would see day as a place and night as a place. That kind of blew my mind to think about that. But that's super cool. Entirely different types of species would form. The only areas that would really be habitable would be called twilight areas. The areas where the sun is not hitting directly, where basically the sun would be along the horizon most of the time. And there wouldn't be any seasons. There wouldn't be any cycles. And unless the planet was on a tilt, if it was tilted on an axis and was spinning around the planet like this, then you would basically just see the sun in the sky going around in a circle over the course of a week or so. But a week wouldn't mean anything to you on a planet like that because time would be a very abstract concept. Think about this. The only thing that would give away time would be, if you had a stick in the ground, and if the planet was tilted, you would be able to see, like a sundial, the sun going around, the shadows going around in a circle. That would be the only way you would be able to tell time. There wouldn't be any seasons on, the life that's there. Plants wouldn't be, wouldn't be blooming, and then it's a very weird thing to think about. You don't think about how much night and day and seasons and the cycles of our planet really affect our thinking until you imagine yourself in a place that didn't have any of those. And then it gets really bizarre and really abstract. And another thing to think about is if you lived on a planet that was perpetual sun, you wouldn't know that stars existed. You would never see stars unless maybe, I guess, if there was an eclipse, there might be an eclipse that came across, and then you'd be able to see stars. And think about how relevatory that would be and how important that would be culturally to people who lived on a planet like that, that you never saw. Like, it wouldn't just be that the sun goes dark. It's that the sun goes dark, and then there's suddenly all these lights, all these pinpricks of light out there that you never knew were there before. That would be astonishing to somebody that lived there. And I also can't help but think about, like, again, that circle of the sun in the sky. And, if you had a sundial kind of thing in the calendar, like the circle would probably be a very important cultural symbol, religiously, culturally, however you want to put it, to people that lived on a planet like that. These are the things that I start thinking of, and I think it's just really super cool to imagine that kind of thing. What else? Let me think here. I think I've covered all that, but yeah, the only habitable areas of a planet like that would be around the edges of it. There might be some explorers that go off to the other side where it's cold. It might actually be warm enough in some areas because of, again, the movement of air, that you might be in an area that's always night and you don't see the sun, but it's still warm enough for life to form and stuff like that. You might not be able to go too far the other direction before it just becomes way too cold. I think a little bit about Game of Thrones, actually, when I think about this, how the north is always like, beyond the wall. It's, wildlings out there and White Walkers and creatures that evolved in a completely different way. I could see something like that happening on a planet like this, like, completely different types of creatures evolved on the other side of the planet. Maybe they're scary, maybe there's class differences. You put up walls to keep people away. I don't know, you get going down some really weird rabbit holes when you start thinking about all that. But that's all we know right now. I think I've covered everything that I took notes on. So that's the TRAPPIST-1 system. And we're going to learn a lot more about it when the James Webb Space Telescope goes up in 2018. We're going to learn a lot more about a lot of things. Really super cool telescope. But that's the story. TRAPPIST-1, 7 planets, 3 of them in the habitable zone, possible water, who knows, maybe life. We're going to be checking it out. And let's hear what you think about it now. I'm going to take a little sip. Do I have any other pictures that I didn't show? I do have this one. Let me just show you this one. This is a picture that I found. Okay, so that's the habitable zone thing. So this is the TRAPPIST-1 system against our own system. So the one on top is enlarged 25 times. So all of these planets are well inside the orbit of Mercury, which is just crazy and fascinating to me. Anyway, so we have talked about TRAPPIST-1. Everything about this sounds like some kind of sci-fi movie, doesn't it? TRAPPIST-1, or like maybe they're trap beat musicians. Trappist. That's new. There's going to be an album out from TRAPPIST-1 coming soon. Okay, so I'm going to jump into the live chats. I can answer some questions and respond to what you guys have said. You guys are like all talking back and forth with each other. That's nice. By the way, let me ask to all these people who might have watched some of my other live streams, I'm clearly doing something different now. I am using my camera, but I am now using it with an HDMI input. I've gotten all these technical things hopefully worked out. Tell me what you think, how it looks, how it sounds. Because if I got this set up and if this works, thank God, I can actually do these live streams and it won't be like some big cluster every single time. Gray asks, Joe, I have a question for you. Do you like Neil deGrasse Tyson? Yeah, I like Neil deGrasse Tyson. Who doesn't? Why wouldn't I? Sometimes when I watch the Cosmos series, I feel like he gets a little too dramatic with his talking. But that's all right. He's doing a great job. I love Neil deGrasse Tyson. I listen to Star Talk Radio, the podcast, all the time. He's awesome. What else we got here? They are so close yet so far, says Vincent Delorme. Yeah, so they are 30 light years away. I heard the guy or the lady from NASA said that obviously if you were traveling the speed of light, you get there in 30 years, but at our conventional fastest speeds, it would take like 2 million years or something like that. It's not a place we could go to anytime soon, unfortunately. Flying Monkey says volume. Is the volume low? Are y'all having trouble hearing me? And it's out of sync. There's a bit of a visual delay. There's always a delay on this thing. I'm going to have to watch back, because everything is out of sync from my side. I can never tell if I'm in sync or not. I have to watch it later on. Yeah, Jetton's saying that's out of sync. Beto Chagas says, life there may not have a sleeping pattern. Yeah, so that's something else, actually, I meant to touch on. So without a night and day cycle, would animals on a planet like that have to sleep? There's one side that says that, well, sleeping serves a purpose other than being cyclical and all that, because your brain has to like process and shut down while it can defrag basically your internal hard drive kind of thing. But there are animals that sleep, sort of that do a hybrid sleep half awake thing, like dolphins. They do hemispherical sleep. They can sleep in your right side of their brain while their left side is awake. So it could be possible that life could evolve in that way in a system like that. So that's kind of cool. Brian Jackson asked, do you believe we just discovered other life in the TRAPPIST system? I think it's too early to say. It's too early to say until we find out whether or not it's the planets are tidally locked. If they're not tidally locked and they're in the habitable zone and we find organic compounds in their atmospheres, or we find similar atmospheres to Earth, that's when I'm going to get excited. That's going to be awesome. But we're not there yet. Do I like living on the oblate spheroid, asked Steve Antonios. It's the only oblate spheroid I have. And I can't even apparently say it correctly, so sure. It's all I got, man. That's all I got. Guy01 liked my impression of Tyson. Appreciate that. La 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 la. Michael says the volume is low and it's out of sync, and it's best not to look at my face because that, dude, it's best not to look at my face for a lot of reasons. Let's just make sure we're all clear about that. So Hal 9000 asked, all of them are tidally locked. Why the universe hates us so much? So, I'm gonna snap at you, bruh, because the funny thing is, when you start talking about these tidally locked systems, again, you have to kind of look at Jupiter's system. To look at the TRAPPIST-1 system, Jupiter's moon system really is the best comparison that you can make. Because, and I could be wrong about this, but I believe a lot of the planets in the Jupiter system are tidally locked as well. So when you say, why does the universe hate us? I say, we're the exception. Earth is not, Earth in many, 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 many ways is the exception to what we see out there in the universe. The fact that we have a large moon, one large moon that stabilizes our orbit, the fact that we are not tidally locked when you start to look at it, being tidally locked might be more of a common feature than not. And in fact, the moon might have helped the fact that we're not tidally locked because it's constantly kind of pulling us with its own rotation. So I would argue the universe likes us very much because it went out of our way to put us here. Now we're getting into philosophy. Can I expand on the James Webb Space Telescope? Asks Guy 1. Yeah, I really do want to do a full video about it because there's a lot of visuals I got to put in front of you. Basically, you know, it's kind of hard to explain if I don't have it to show, but it's going to be, I believe, like the Spitzer telescope. The Spitzer telescope is actually not orbiting around Earth. It's actually trailing behind us at one of the Lagrange points. So that gives it completely, it's completely away from all of our Earth crap and gives it a more crystal clear image. I believe the James Webb Space Telescope is going to do the same thing. Don't hold me to that. But it's got like several layers of heat shielding on the bottom of it that I believe it's like the size of a tennis court. So it's a huge satellite and a huge telescope. And whereas, and I'm going to get the numbers wrong because I'm just pulling them out of my butt, but the Hubble Space Telescope, I'm going to say, is maybe like 12 meters. That seems too big. Actually, it's more like, I think, 6 meters. Anyway, the James Webb Space Telescope is going to be like 10 times bigger in terms of mirror size. They've got like all these different mirrors that are going to fold together, and when it launches, it's going to go out like that. And it's going to have just this gigantic collection of this gigantic photon collector to be able to pick up on photons that are flying at us from almost the Big Bang. I think that's really the thing that's going to be most useful for, is being able to see literally back to just, you know, maybe a few million years after the Big Bang. So we're going to get all kinds of new perspectives from the James Webb Space Telescope. It's really cool. They've been working on it for a really long time. And the fact that it's finally launching next year is really exciting. All right. What else we got? Oh, we got 122 people watching now. Thanks, guys. Thanks for checking in. Let's see. So, I'm gonna say your name wrong, dude. I apologize. Gaurav Menwani. What are the odds comparison of life on Europa and TRAPPIST planets? I want an answer. Well, I don't know that I could give you that right off the top of my head. I mean, Europa is an interesting place, and they're talking about getting, what do you call them, drones, satellites, whatever. The underwater drones. There's an underwater drone that is being worked on. I don't know how close they are to actually making it, that they're going to land on Europa, and it's going to drill through the ice and actually swim around. It's kind of like a mechanical squid kind of thing. That's awesome, and I would look forward to that happening. Let's see. What else we got? Oh, I have a super chat. Who was that? Blake Porter. Huge fan of your videos. Keep up the great content. Thank you so much, Blake. And I only saw that for some reason because who called you out? Greg called you out. And he's thanking you. Everybody thank Greg. Or I'm sorry, Blake. Blake Porter. I said Greg because I know a guy named Greg Porter who also has a channel called Greg's Garage. He's awesome. But thank you, Blake. That was super cool. I appreciate that. Hubble has a 6-foot mirror. Nailed it. Got it. I mean, I got it wrong at first, but I eventually nailed it. So okay, so some people are correcting me here. That's awesome. So Hubble has a 2.5. Okay, now we got it. Now we got some back and forth going on. Hubble has a 2.5 meter mirror. James Webb will have a 6 meter diameter. Are you sure about that? Okay, so What a World was talking about feet, and now we're going into meters. 6 meters. I thought it was bigger than that, honestly. But it's still vastly bigger than Hubble. That's the whole point. So, what else we got? Oh, we got another super chat. Brian Jackson, $10. Thank you, Brian. Very much. Everybody give Brian a pat on the back. He's the hero today. What would life on Titan be like? Asked Crazy Leica. Titan has a methane atmosphere, frozen methane hydrates on the ground. It would be super, super, super cold. Probably, I would imagine you're not going to find much more than microbial life if we did find some there. That's my bet. Gwep Ferngully asked, "Hey Joe, what research are you most excited about?" Wow, that's a big that's a big ground to cover. What research am I excited about? Because I'm excited about a lot of things that aren't just like astronomy, cosmology related. I got to be honest, and maybe this is just very selfish. I think the things that I'm most excited about are the research into aging and living longer, life extension, that kind of stuff. There's some really interesting stuff going on, and there's a lot of people talking about that in the next 30 years or so we're gonna crack that nut, and we'll be able to live for a very long time, and that excites me because, like I've talked before, I have future FOMO. I feel like there's a lot of things that are just outside my lifespan that are going to be really, really cool that I'm going to miss out on, and I don't want to miss out on them. I want to see them. It's not just about the fact that I don't want to die. Of course, I don't want to die, but there's a lot of cool stuff that's on the way, I feel like, and I want to see it. So the idea that this research is happening that could extend all of our lives possibly indefinitely, that's super exciting to me. I am behind on chats here. Let me catch up here. With our current fastest ship, it would take us around 14,000 years to get to those planets. Aren't we overreacting to these discoveries? That's Jonalisis Marade. Hope I said that right. See, that's always the cold water you got to throw on it. You find these really cool things out there, but it's like we're never going to quite get there unless we develop some kind of warp drive. That's a bummer. So, overreacting, I don't know. I mean, it's not just about whether we're going to get there, whether we can get there and see it ourselves. That's not really the point. The point is if, like I always say, if we are able to find even microbial life on Europa or Titan or any of these other places in our solar system, that would be such a gigantic discovery. And I'm just talking about in our solar system. Obviously, if there were proof of life in places like TRAPPIST, that would be exciting too. Just for the fact that I think that would shape our view of our place in the universe more than anything that's ever been discovered before, possibly, with the exception of the heliocentric model of the solar system. To be able to see that that this is happening all over, it gets philosophically into a lot of different territories of, maybe the universe is wired for life. Maybe that's the point of the universe, is to make that happen. So that's exciting, whether we can get to go there or not. That's my point, anyway. So Hamza Rashid is cheating the system by putting my name in big orange boxes. So I'm just I'll bite. Any idea about the gravity on those planets? I mean, some of them are really big. It's a pretty good question. I think they're pretty similar to Earth. I think that was part of the whole thing. I mean, they're the same relative density, and they're the same size and mass, roughly close to the same size and mass of Earth. So I would imagine they'd be pretty close to what we have here. I'm only assuming, though. Juan Borges. Hi, guys. Hi back. How are you? Do you think there's actually life on any of these exoplanets? I think I've kind of covered that. That was JK Origami. Appreciate the question. Is this solar system imaginary? Asks Steve. Wait a second. What are you referring to there? I thought it exists and we can see it. Maybe you're referring to somebody else, but Guy01 wants me to do my Stephen Hawking impression next. I will not do that. I like Stephen Hawking too much to do that. Stefan says, even if we did find aliens, wouldn't they have to be similar to us, maybe in looks or biology? They wouldn't have to be. I don't think. You know, you can look at octopuses. They look nothing at all like us, yet they're incredibly intelligent. They're not as intelligent, you know, obviously, as we are, so far as we know. Maybe they're doing calculus and we don't even know it. That gets into a lot of questions, actually. Like, you know, if you met an alien species that had different number of digits, different number of appendages, you know, I mean, we have a base 10 number system. Why? Because of this. So what would their number system look like? You know, how would you even make that? How would you even, you know, interact? I mean, it's an interesting thought. Anyway. All right, so I'm going to take just a couple more questions. It's been about 40 minutes. I really appreciate you guys joining. We've still got almost 120 people. This is like by far way above my biggest live audience. You guys must be interested in this subject. Or me. Maybe it's just me. No, it's the subject. Okay. Yeah, Juan's asking if I've done Isaac Arthur's video. We've collaborated before, and that was awesome. I have some plans to use these live streams to do interviews with people, and I was going to reach out to him about that, but I haven't gotten all the technical aspects figured out just yet. So, I could see me doing more with Isaac. He's a really great guy. So, oh, Brian just sent another. He put a note on there. I'm going to give you another 2 because I forgot to type on the last one. Ha ha ha. Just wanted to say thank you for all the videos, Joe. You do an amazing job. Thank you, Brian. Brian, everybody. Dun, 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 dun. That's the super chat sound. I'm not going to do that again. Okay, sorry. Brian, thank you very much. I appreciate that. I got a lot of really cool stuff in the way, guys. I'm really excited about it. Between these live chats, which by the way, I never actually spoke about this. I'm going to be trying to do these every Thursday now. So those of you who are following know that I was doing them every day at the beginning of February. Wasn't working out so great. I had a lot of technical issues to work through. I've mostly got them all figured out. Clearly, there's still a sound issue for some people, but I'm going to be doing these every Thursday now on, you know, trending topics, stories that are out there, kind of more newsy type stuff like this. You know, just happened yesterday. And I hope to do interviews through this. I do have a podcast in the works. There's a website up now that a couple of really great guys, Jatin. I want to make sure I'm saying your name right. If you could correct me in the live chat there. How do you pronounce your name? Is it Jatin? I want to know because I don't want to get your name wrong. But he has been helping me out immensely with a website. There's a website up. It is answerswithjoe.com. And I'm going to be funneling all kinds of cool stuff in there. Live streams, podcasts, videos. I'm going to be blogging on there. There's going to be a lot of cool stuff. And I'm about to combine my Facebook page with another Facebook page. So the Facebook page is about to get a lot more active and a lot more interesting. There's a lot of stuff going on. And this is just a small part of it. I had another couple of super chats come in. Heroes Burger, €5. Nice. It's mostly the subject, but we really like you too. Oh, thank you very much. Thanks for all the hard work. Thank you, Heroes. Heroes? I'm just going to say Heroes. And Brandon Allaire, $2. Thank you very much, dude. Wow, feeling some love, man. Oh, I appreciate it. Hopefully these live streams will continue to improve because I'm still a little rough around the edges. I get a little nervous when I first hit, you know, the button because, oh my God, people are looking at me now. So I'm doing my best. But Brandon says, always enjoy your content. Thank you very much. I appreciate that. I enjoy doing these. History Cot 835. Would I go to Mars? Would you go to Mars if you could go? You didn't word that badly. I just read it weird. Okay, wait, really quick. So Jatin? Is it Jatin? You said the first one. I don't know which one I did first. It'll catch up in a second. Anyway, to answer the question, would I go to Mars if I could go? Oh my God. So, guys, I'm a coward. I'll say it. I'm a coward. I would love to go to Mars, but not until it's like basically like flying to New York or something like that. I'm not going to be one of the people that's like, I'm going to die on Mars. I have no interest in that. Sorry. I want to live, man. I want life extension. The idea of going there is awesome, though. So that's my answer. If they ever really like get it down, yeah, I would absolutely go. Okay, one more question, and I gotta go. Gray is thanking Brandon and Heroes for helping me out. That's so cool, man. You like calling out your buddies, and I appreciate that. Jatin, okay. Jatin, I'm gonna go with Jatin from now on. Okay, so one more. David K, which of the planets is your favorite? This is a cheap answer, bro, but I gotta go with Earth, man. I mean, this is our home. This is where we live. I love the stories from the Apollo astronauts where they went to the moon and turned around and looked at the Earth, and like they said, they just couldn't stop looking at the Earth. It was just like this beautiful blue marble in the sky, and it's full of life, and it is, to the best of our knowledge right now, the most extraordinary and singular place in the universe. And it's our home and we live here, so that's my pick. Sorry if that's stupid, but I believe strongly in that. So, okay, on that note, guys, thank you so much to people who super chatted. You certainly didn't have to do that, and I totally appreciate it so much. All the people who are joining, I hope you enjoyed this. Feedback anytime, please. If you're watching this after the fact, then you are really sticking around for a long time. I appreciate that, but feedback in the comments is appreciated. Thoughts, concerns, I want to hear it all. Thank you guys so much. I am signing off now. I hope you have a great rest of the week. Have a good weekend coming up, and I'll be back on Monday. Got a video in the works, so I hope you enjoy it. You guys take care. I am signing off, and let's make sure I do this right, people. Love you guys. Take care.